Hi, my name is Muhammad Iqbal Shoki bin Hassan. My metric number is 201110794. Okay, what is Renold Trannsport Theorem? Renold Trannsport Theorem is a fundamental result in fluid dynamics and continuum mechanics that bridge the relationship between a system and a value. It is essentially a mathematical tool used to derive the conservation law of mass, momentum, and energy for a control value in fluid mechanics. RTT provides a way to analyze the time rate of change of a property such as mass, momentum, and energy for a system by relating it to a control value through which the fluid flow. It helps in transitioning from a Lagrangian perspective to a Eulerian perspective. Based on figure 4, 66 on a textbook is consider the flow from the left to right through a diverging expanding portion of a flow field as sketched in figure. The upper and lower bound of the fluid under consideration are streamline of the flow, and we assume the uniform flow through any cross section between these two streamlines. We also choose the control value to be fit between section 1 and 2 of the flow field. Both 1 and 2 are normal to the direction of flow. At some initial time t, the system considered with the control value, and thus the system and the control system are identical. During the time interval, the system moves in the flow direction at uniform speed at section 1 and v2 at the section 2. The system at this later time is indicated by the hatch region. The region undercovered by the system during this motion is designed at section 1, and the new region is covered by the system is designed at section 2. Therefore, at time t plus delta t, the system consists of the same flux, but it occupied the region CV minus 1 minus region 1 plus region 2. The control value is fit in space, and thus it remains as a shaded region marked CV at all of the time. Let capital B present any intensive property such as mass, energy, or momentum, and let B present B per M represent the corresponding intensive property. Noting that intensive property are additive and intensive property capital B of the system all at time t and t plus delta t is expressed as B system equal B CV. After that, B system t plus delta t equal to B CV t plus delta t minus B1 t plus delta t plus B2 t plus delta t. After subtracting the first equation from the second one and dividing by delta t give, we get B system t plus delta t minus B system t over delta t is equal to B CV t delta t minus B CV t over delta t, and minus B1 t plus delta t over delta t, and plus B2 t delta t over delta t. After taking the limit at delta t equal to 0 and using the definition of derivative, we get the equation 438 is dB system over dt equal dB CV over dt minus b in and plus b out. Based on equation 440, the properties with the control value may vary with position in general. Such a case, the total amount of property B within the control value must be determined by integration. The equation is BCV equal to integrate CV PB dV. To get the equation 441, we must substituting the equation 439 and 440 into equation 438, yield the Renold Trannsport Theorem, also known the system to control value transformation for a fit control value. The equation is dB system over dt equal to d over dt integrate rho b dv plus integrate rho b v and multiply n dA.